find the electric potential at P and Q, right? Okay. So what we do, remember, is that we're just going to simply add the voltages as scalars, and that's just the beautiful thing, right? So my voltage at P is going to be K times, and then charge A is negative 6.1 microcoulombs, right? Divided by, and then since it's R and not R squared, right, we're going to go 2 over 1 down, right? So it's going to be the square root of 2 squared plus 1 squared. Okay, 2 over 1 down. So that's the contribution due to A, but don't forget there's a contribution due to B, right? So that's going to be K times positive 4.3. When I say micro, I'm going to type in, times 10 to the minus 6 and all that good stuff. And then B is at point P is 2 over 2 and 1, 2, 3, 4 down. So square root of 2 squared plus 4 squared. Okay. Just want to make sure I'm not, look at my notes here. Oh, more notes. More notes. There they are. Okay. Yeah, there we go. Okay, so let's figure that out. So I'm going to go alpha F1. I like to do this. So then I'm going to go alpha K times negative 6.1 e minus 6. And then the denominator is going to have the square root of 2 squared plus 1 squared. Then I go right. I'm going to go plus. I'm going to do alpha F1. I'm going to go K times 4.3 microcoulombs. And then in the denominator, the square root of 2 squared plus 4 squared. Okay, so literally there's no components. I'm not going to find any angles. This thing is just literally the scalar sum. Scalar just means like normal. Okay. All right, you ready for this? So this is negative 15,880.8, I'll just say, volts. That's what that one is. Okay, so let's find VQ. That's going to be K times negative 6.1 microcoulombs. And that is over, let's see, Q is how far to A? 2 over, 2 up. 2 squared plus 2 squared, right? So I'm going from Q to A here, right? And then it's going to be K times 4.3 microcoulombs, right? So for K here, of course, I'm using 8.99 times 10 to the 9th. That's what I'm saying. And then let's see, Q to A was 2 over. This one's 2 over 1 down. So notice that the numerator is the same. It's just the denominator changes here. And I'm going to store that in P, storage, alpha P. There's a reason I do that, because I'm kind of a spaz for these things. Okay, so now I'm going to store this guy in Q, but first I got to get the answer. Okay, so I just barfed up this same expression in my calculator, and now I'm just going through it. This one's 2 squared plus 1 squared, so 1. I'm just going through the expression. Okay, so let's see. And then this guy is 2 squared plus 2 squared. 2 squared plus 2 squared. 2 squared plus 1 squared. Okay. And I'm getting that this is just negative 2100.578 volts. Okay. All right, so we found those. We got the right answers. This is good, right? Then we have work to move a positive 105 microcoulomb charge from P to Q. So this is my final voltage. This is my initial voltage. And the change in voltage is always final minus initial. So in this case, it's going to be VQ minus VP. okay? Because it's to this one, right? Final minus initial, okay? So that's going to be, my change in voltage is going to be V. I'm going to store this, by the way, in alpha Q. Okay. So it's going to be VQ minus VP. All right? Is that right? Yeah. So VQ is negative 2100.578 minus a negative 15,880.8 volts. All right. So the change in voltage, if we move it from P to Q, that's what we're doing, right? Okay, the change in voltage is alpha Q minus alpha P is positive 13,780.2 roughly. Okay, so now we're ready, right? Work is Q times change in voltage, right? So that's going to be 105 times 10 to the minus 6, and that's positive, right? Times 13, positive 13,780.2. So times 105, oops, minus 6. I do the minus 6, okay, there we go. This is 1.4469, positive 1.4469 joules, or positive 1.45 joules. Now think about this, right? B is a if we go from P to Q, right? Notice that we were pretty close to this negative charge, and we're getting pretty close to that positive charge. So if you took a positive charge and did that, it's not going to want to do that. That would require a positive amount of work. It's going to fight you. Okay, it should make sense, right? That this is a higher piece of this sheet of rubber. This is a depression in the sheet. That's a mountain on the sheet. So we definitely went uphill, okay, when we did that. So it does make sense to me.